In this question, it asks us for the different types of intermolecular forces between, in this case, iron 3 cation and formaldehyde. So before we do that, I want to talk about the types of intermolecular forces and where they exist. So starting in increasing strength, the smallest strength first, we have dispersion forces. These are induced dipoles present in all molecules. So all molecules have dispersion forces. The next one is dipole-dipole forces. And this is for polar molecules. And this is just meant to be a brief review. You can learn a lot more about this in great detail, but I'm not going to spend time on it here. I'm just going to review this. The next one is H bonding, hydrogen bonding. And that's between, if you have an NH, an OH, or HF. Note that sometimes only one of the two molecules needs to have an N directly bonded to an H, such as a molecule of water can have hydrogen bonding with a molecule that just has a nitrogen in it. It doesn't have a nitrogen directly bonded to a hydrogen. And the last one is ion dipole. And this is between a polar molecule and an ion. And this is the strongest of the intermolecular forces. So let's look at the first case, and we'll actually look at a second case as well. So this is just a quick review of intermolecular forces, and again, I didn't give a lot of details. So the iron 3 cation, that's Fe3+. And the formaldehyde molecule, which is C double bond O, bond H. Bond H. And again, for practice writing intermolecular forces, which is the first step to figuring this out, there are other videos on this channel that you can use. So in this case, we want to list all of the intermolecular forces. Well, dispersion is always going to be on the list, because all molecules have these induced dipole forces that come about by collisions. But in this case, we have a polar molecule. Note the carbon is bonded to 2 hydrogens and an oxygen, so not all the outside groups are the same. So therefore, it is going to be polar. And iron is Fe3+, so it's an ion. So here we have an ion dipole force. In the next case, we're asked for the intermolecular forces acting between 2 xenon atoms. So we have Xe. Note that if an atom is not bonded to anything else, it can't possibly be polar. Note that the polarity comes from the difference in electronegativity. Oxygen is more electronegative than carbon, so this is partially negative and this is partially positive. In the case of xenon, it's not bonded to anything, so therefore it can't possibly be polar. If a molecule is not polar, it can't have dipole-dipole. Clearly, it doesn't have hydrogen bonding, it doesn't have a nitrogen, oxygen, or fluorine, and it's not an ion, so you can't have ion dipole. So the only intermolecular force in this molecule is the dispersion force.